This is 8.4 notes, graphing rational functions. So 8.3 we did reciprocal, now we're doing rational. These are way more advanced than reciprocal. Reciprocal are very easy, there's not a lot of work. These have a ton of work. If you notice on these notes, we only have one question. That's because these questions take some time and some practice getting used to. Okay, so we have to not only find all of this stuff on the right, I have to also graph it with all the right things in the graph. Okay? So let's go down here and do notes. Again, we have this whole page. We're not doing anything else. So I've kind of created or come up with kind of a simplistic chart that we can use to guide us through this. If you want to look at my actual notes, I type out and explain what to do in words using sentences. That's fine too. But I'm going to go ahead and write or create this chart. So, with rational functions, first thing you always want to do before I do anything else is always factor and simplify. Because if I don't do that first off, some of these you won't be able to find. Second, you won't have the correct answer every time either. So always factor and simplify. Alright, so let's start with the first thing. So the first thing we have to find on our list is the X intercept. Okay. So to get X intercept, all I simply do is I'm going to set my top of my equation equal to 0 and solve for X. And then my answer for this, for X intercept, is always going to be whatever my X is, comma 0. Okay? So I set my top equal to 0, solve for X, my answer is X equals 0. So if you want to do like little arrows, however you want to do this, or if you want to redo this completely in your way, that's fine. That's why it's blank. Okay, so that's X intercept. Let's do, well, as soon as it'll let me. Alright, so that's it for that one. We can go ahead and draw this line. So we're done with X intercept. That's all we gotta do there. Now again, this is after you factor and simplify. Okay, next thing on our list to find is VA. That is vertical asymptote. If you want to write that out, feel free to. I'm not going to. So to find vertical asymptote, I am going to set the bottom equal to 0. Okay? And then again, I still solve for X. And then my answer is just X equals, you know, whatever number that I find. That's it. Okay? I'm not really going to say that it's always it's not always positive, it's not always negative. I don't want to put a letter there. It's just X equals whatever you get. Okay? So that's it for vertical asymptote. So we can draw a line. Alright, next one. This one's going to take up probably the most space. So we have SA/HA. So we've talked about HA, right? So HA is horizontal asymptote. VA is vertical asymptote. So SA is called a slant asymptote. Sometimes people call it oblique just because it's not vertical, horizontal. It's still a straight line. It's just slanted. You know, it's diagonally going either up to the right, down to the right, it just depends. Okay, so SA and HA. So first off, you have to figure out which one it is and then go from there. So there are 3 ways that you can go from this kind of question, and the way you do that for all 3 of these is I want to look at my degrees. My degrees will determine which one I have and how to find it. Okay, so degrees. So when I say degrees, remember I'm talking about, if you want to write this down, That just means highest exponent. Okay, so I'm talking about degrees, I'm talking about the highest exponent. So after you have factored and simplified, you're left with whatever function you have left. You'll have an exponent on top and an exponent on bottom. Those are my degrees. So when I look at those, I can have three things, right? I can have the top degree is less than the bottom degree. You know, the highest exponent on top, let's say, is a 2, and then the highest exponent on bottom, let's say, is a 5. The 5 would be bigger, greater, you know, it's a bigger number. So if my top degree is less than my bottom degree, that would give me an HA, okay, so horizontal. And then if my top is less than my bottom, I have an HA, my answer is simply y equals 0 for that scenario. So on this one, it's the easiest one to do because there's no work. Okay, now I have the next one. Let's say my top degree is equal, you know, the exact same as my bottom degree. That would also give me an HA, a horizontal. And then the way I would solve that is I would have to do my, let's just call it top first number divided by bottom first number. Okay, and I guess I didn't really leave room. I apologize. It should also be y equals, okay. So y equals, so it's a leading coefficient is what it's called technically, but let's just say it's the first number. So we will actually have that in this question, so I'll be able to show you what that looks like. But simply, like, say my highest exponent in the top was a 3 and my highest exponent in the bottom was also a 3, I would take the two first numbers, the two leading coefficients, and just divide them into either a whole number, or if they don't divide, they just simplify to a fraction, and that would be my horizontal asymptote. Okay? So again, that one's not too bad. It's a little easier. And wow, I write awfully big for this. Gee, you may need some extra room. Okay, the last scenario I can have is I can have a top number greater than the bottom. This would be the only time that it would give me a slant asymptote, which you will see this on the homework. And if I have that scenario, I have a slant asymptote, I have to use synthetic division. And then it would give me an entire equation, and that would be my asymptote. So I only did that, I think, twice for the homework. I'm not really going to focus as much on the slant asymptote. I just want you to know that it does exist and how to find it. That way, in case you ever see it, either in college or on the SAT or whatever, you at least are familiar and can get somewhat of a close answer. So most of these, though, are going to be the first two. I'm going to focus on horizontal asymptotes. But just know you will see a few slant asymptotes, and I do want you to know how to get them. All right. So we have X intercepts, we have vertical asymptote, we have slant and horizontal asymptote. The next thing on our list to find, see, I write big on here. I probably should have written out everything first. That way I don't take up so much room. Okay, so the next one, though, is the hole. And this is like a hole in the graph, a point that does not exist. So if you're drawing a line and then you pick your pen or pencil up, move over past a point, and then you keep drawing the line, that would be a hole. It's just missing. It does not exist. So to find the hole in my graph, so when you factor and simplify, I will say not always, but sometimes, oftentimes, you will end up having to cross out some parentheses, right? So if I ever have anything crossed out, I'm going to take what I crossed out and set it equal to 0. Okay? So like if I have a parentheses, it's like, say it's 2x plus 1, and I have that on the top and the bottom, and so they cancel out, right? Then later I would take 2x plus 1 equals 0, and I would solve for x. Once I solve for x, though, I plug x into my equation for y, because a whole is actually a point, so my answer would be x comma y. So the whole is a point, so you have to have both numbers. You can't just find one and just guess. So you have to find both. So you find x, you plug it in, find y, that's my whole. That's the point that does not exist. Okay? And I've already gone over domain and range before on reciprocal. It's pretty much the same for here. If you have room still because you write small, which is great, or if you just need to write it somewhere else for domain, there's just one extra thing we have to write. So I'm still going to do x such that x does not equal, and it's still my vertical asymptote, but it's also the x value of the whole if I have one. Okay? Oh, that was bad. So I might have two numbers, and if I don't have a whole, then I won't. I only have one. So just like reciprocal, I'm going to say my x does not equal my vertical asymptote because it can never actually go to that point, right? And then the range, same thing. So my range, I'm still going to do y such that y does not equal k, or not k, I'm sorry, we don't have a k. So I'm thinking of that. It's HA, my horizontal. And also, if I have one, my y value of the whole that I found. Of whole, okay. So that's domain and range. And then that would be the entire thing. And then you just got to put it together on a graph to show what it looks like. Which, again, I'll show you that. There's really not much to write down as far as instructions. I'll just show you how I do it. Okay. So let's go to this problem. This is the only problem for this video. And again, see, it took a while to explain what to do in the notes and all that, but now we'll put it into action. It won't be that bad, I promise. So I have to factor and simplify first. So if I look at the top, I can't factor because I don't have three terms, but I can take out a GCF, right? So it's still factoring. So I can factor out a GCF. So here I'm going to divide by, I can divide out a 2 and an x. Okay? And on the bottom, I have three terms, so I can factor doing the first times the last. Okay, so let me go down here and just do y equals, let's see on the top, my GCF goes out front, so I have 2x. I'm going to try and write a little smaller just in case I want to run out of room again. So if I divide 2 by 2, I get 1. X squared by x, I get x. And then minus 6 divided by 2 is 3. Okay, so 1x minus 3. Or if you're one of those that you don't like to write the 1, x minus 3, same thing. All over. So on the bottom, I'm going to have two parentheses. And they both start with x. And two numbers that multiply to 12, add to negative 7 would be minus 4, minus 3. Okay, so look at that. I can now cancel out or cross out these two parentheses because they are the exact same thing. So I'm actually left with y equals 2x over x minus 4. Okay? So that's my actual equation I'm going to work with for the rest of this. Alright, so the first thing, I'm going to try and change colors up for all of this. So first thing, draw a line. I have x intercept. So for my x intercept, remember I do the top equals 0. So my top on this one is 2x equals 0. If I divide by 2, I get x equals 0. So then my x-intercept, remember, is my x comma 0. So it's actually 0 comma 0. Okay, that's it. So see, these aren't, it's not too bad to do these. It's just knowing what to do and how to write the answers correctly. But the work itself isn't too difficult. All right, next thing is vertical asymptote. So for vertical asymptote, I set the bottom equal to 0 and solve for x, right? So the bottom of my equation, x minus 4 equals 0. So if I add 4 to both sides, I would get x equals 4. So that would be my answer, x equals 4. All right, next one. I have to determine if I have a slant or a horizontal asymptote. So remember, if I look at my degrees, my top and bottom degrees are my highest exponents. They're either going to be the same or one of them is bigger than the other. So if I look at these, I have my highest exponent on top is just the x to the 1. So it's a 1. And then the bottom is also x to the 1. So my highest exponent for both are equal. So if you look down at that chart that we made on your notes, if the top and bottom are equal degrees, I have a horizontal asymptote. So I'm going to write not in highlighter. I'm going to write HA because I know I have a horizontal, and I'm going to do the first number on top divided by the first number on bottom. So my first number on top is a 2. So I have y equals the first number on top divided by first number on bottom. Remember, if there's not 1, if it's just x, it's actually 1. Okay? So 2 over 1. If I reduce that, which I can, 2 divided by 1 is simply 2. And that would be my horizontal asymptote. Alright, next one. So, hole, you only have a hole in your graph if you cross something out. So I crossed something out. So to find what my hole would be, I'm going to do whatever I crossed out equal to 0, and I cross out x minus 3 equals 0. So if I add 3 to both sides, my x value would be 3, and then I have to plug that in to find the y. Okay, so I'm going to use my equation right here that I simplified. I don't want to use the original. Okay. So y equals 2x over x minus 4. So I'm going to have y equals 2x, which is 3, over 3 minus 4. So all you do is plug this x in for x on the equation and solve for y. So I have y equals 2 times 3 is 6 on top. 3 minus 4 is negative 1. Y equals negative 1. So then the whole is a point, right? It's always x and y. So my whole would be 3 comma negative 1. Look at that. We fit all of that into the box in the space provided. So it can be done. Alright, so now I'm not going to do domain and range over here. I'm just going to write it later because we kind of use the answers above to get that anyway. So I'm going to go ahead and go over here and start writing my answers. So my x-intercept, if I look over on the left, is 0 comma 0. Okay, vertical asymptote is x equals 4. See where it says SA/HA? So you can't have both. So that means you're going to have to circle the one that you do have, and you can cross out the other one. I have a horizontal, and it is y equals 2. The hole that I found down here in the green would be 3 comma negative 1. Okay. Now I can do domain and range. So domain, I have x such that x does not equal, and if you remember, my domain is going to be VA and my x value of my hole. So it does not equal my vertical asymptote, which is 4, and then the hole, the x value is 3. Okay, that's my domain. My range, very similar. Y such that y does not equal. This one is going to be HA and then y value. So HA is 2, y value is -1. Now if I had an SA, a slant asymptote, it'd be a little different. So if you ever have a slant asymptote, your range is going to be all real numbers. Just letting you know. Maybe you can go back and write that down here somewhere. So I use synthetic division, and then also range equals all real numbers if I have a slant asymptote. And if you look at the homework later, they're on the one that has a slant asymptote, you'll see why on the picture. Okay, so I did all of these. Now I have to put it on a graph. Okay. Now, the best way that I do these, and this is why these are in a certain order, is I actually draw everything on the graph in the order that it appears on the right. Okay, so the first thing I would do is plot X intercept, which is 0, 0. So I put a point there. Okay. Then I'm going to draw a dotted line on the vertical asymptote. So I go over to 4 and I do a vertical dotted line. Okay, then the next thing I do is horizontal. So I go to y equals 2. I do a horizontal asymptote dotted line. Okay. Next thing, since I have a hole, I have to put this on here. If I don't, you ignore it. So for the hole, it's going to be different. I'm not going to put a point there because remember, this point does not exist. It's like it's a hole in the ground. It's missing. You're going to skip over it. So I go to this point. So I'm going to go to 3, 1. And instead of drawing a point, I'm actually going to draw a circle around that point to let me know when I get there, I'm going to skip over that and then continue going. Okay, and then I don't need to write domain and range. You can't put that on a graph anyways. So from here, I'm going to go ahead and draw my graph. Now, if I notice, I have my dotted lines and I cut my graph into 4. The same thing as the last lesson. Now, on this one, I can't always tell you that the positive negative thing works as far as which corners to go in. But that's why that we find the x-intercept at least, and then if you have one, because see where I have a point. Now don't draw this part. I have a point right here. Okay. So here's a point that I have. If I have a point in the bottom left corner, that means my graph has to be in the bottom left corner. If my x-intercept was over here, don't draw this, then my graph would be in the bottom right corner, and then I would go opposite of that. So I'd always recommend starting to draw your line, your graph, in the corner where your x-intercept is. So let's do that. So my x-intercept is in the bottom left. So I'm going to draw a line. I'm going to be as close to the dotted line as I can, and then I'm going to go through. Oh, that's terrible. Okay, so I'm going to go through my point, and I'm going to hit the hole right here. But remember, I don't want to draw inside that circle, and so then I'm going to go on the other side and just go straight down. Okay, so I should be going through the x-intercept, and I skip around that circle, that hole that doesn't exist. Now, here's the easy part. Wherever I start my graph, so I started in the bottom left, just like reciprocal functions, the other side, or other half of my graph, is going to be diagonally across from that. So if I'm in the bottom left, my other side is going to be in the top right. So they should always be diagonally across. They should never be on top of each other or right next to each other. There should be no up and down or left and right. It's always diagonally across. Okay. So if you start on the one that has the x-intercept and just go diagonally across from that, that's your other side. That's how I do these. They can be together on the same side, top and bottom, or left and right, but that's only if you have absolute value functions and stuff like that, which we are not doing. So again, wherever you start in, whatever corner you start in, go diagonally across, and that's your other corner. So that is it for graphing rational functions. Again, this is just, it seems like a lot. That's why there's only a few questions on the homework, but I would still definitely practice all this because this will be on the test.